Mars plays shepherd to our moon's long-lost twin, according to what scientists have found. This is by Apostolos Christou, Armagh Observatory. It's on phys.org. And we have a depiction of the planet Mars and its retinue of Trojans circling around L4 and L5 Lagrange points. The dashed curve traces the planet's orbit. At L5, on the right, we have asteroid 101429. It's represented by the blue point. And the asteroid Eureka and its family are represented in red and amber, respectively. An international team of planetary scientists led by astronomers at AOP have found an asteroid trailing behind Mars with a composition very similar to the moon's. The asteroid could be an ancient piece of debris dating back to the gigantic impacts that formed the moon and other rocky planets in our solar system, like Mars and the Earth. If you see the video before this one, researchers recently found that it only took about 40,000 to 200,000 years for the formation of our solar system. Now, anyway, going back to this, the asteroid could be an ancient piece of debris dating back to the gigantic impacts that formed the moon and other rocky planets in our solar system like Mars and Earth. The research, which was published in journal Icarus, also has implications for finding such primordial objects associated with our own planet. Trojan asteroids. They're a class of asteroids that follows the planets in their orbits as a flock of sheep might follow a shepherd trapped within gravitational safe havens, quote unquote, 60 degrees in front of and behind the planet. They are of great interest to scientists as they represent leftover material from the formation and early evolution of our solar system. Several thousand of those Trojan asteroids exist along the orbit of the giant planet Jupiter, and closer to the Sun, astronomers have so far discovered only a handful of Trojans of Mars, the planet next door to us, to our Earth. The team included scientists from Italy, Bulgaria, and the US, and led by the Armagh Observatory and Planetarium, AOP for short. It's in Northern Ireland and has been studying the Trojans of Mars to understand what they tell us about the early history of the inner worlds of our solar system, the so-called terrestrial planets, but also to inform searchers for Trojans of the Earth. Ironically, it's much easier to find Trojans of Mars than for our own planet, because these Earth Trojans, if they exist, sit always close to the Sun in the sky where it's difficult to point the telescope. So they could be there, it's just that we can't see them because the big telescopes space agencies have can't dip that far to the horizon and to see towards the Sun. That's why we have the interstellar comets that have recently been found by amateur astronomers that have their telescopes able to point down towards the horizon facing the Sun, and that's how they saw them. Now, going back to this, an Earth Trojan named 210 TK7 was found a decade ago by NASA's WISE space telescope, but computer modeling showed it is a temporary visitor from the belt of asteroids between Mars and Jupiter, rather than a relic planetesimal from Earth's formation. To find out the composition of the Mars Trojans, the team used X-Shooter, a spectrograph mounted on the European Southern Observatory 8mm Very Large Telescope, VLT for short, it's in Chile. The X-Shooter looks at how the surface of the asteroid reflects sunlight of different colors, its reflectance spectrum. By performing the spectral comparison with other solar system bodies with known compositions, a process called taxonomy, the team hoped to determine if this asteroid is made by a material similar to the rocky planets like our Earth, or if it's a piece of carbon and water-rich material, typically of the outer solar system beyond Jupiter. Now, one of the Trojans the team looked at was asteroid 101429, 1998 VF31. Existing color data on the object suggested a composition similar to a common class of meteorites called ordinary chondrites. The light collected power of the VLT very large telescope, allowed to gather higher quality data on this asteroid than ever before. By combining these new measurements with data obtained previously with NASA's Infrared Telescope facility in Hawaii, the team then tried to classify 101429. They found that the spectrum did not match well with any particular type of meteorite or asteroid, and as a result expanded their analysis to include spectra from other types of surfaces. To their surprise, they found that the best spectral match was not in other small bodies, but with our nearest neighbor, the Moon. As Dr. Gavin Borisov, a PDRA and AOP at AOP, who was deeply involved in the spectral analysis, explains, Dr. Borisov said, many of the spectra we have for asteroids are not very different from the Moon, but when you look closely, there are important differences. For example, the shapes and depth of broad spectral absorptions at wavelengths of 1 and 2 microns. However, the spectrum of this particular asteroid seems to be almost a dead ringer for parts of the Moon, where there is exposed bedrock such as crater interiors and mountains, he said. Where could such an unusual object have come from? One possibility is that 101429 is just another asteroid, similar perhaps to ordinary chondrite meteorites, that acquired its lunar-like appearance through eons of exposure to solar radiation, a process called space weathering. Alternatively, the asteroid may look like a moon because it does come from the Moon. Dr. Apostolos Christou, AOP astronomer and lead author of the paper, explains, the early solar system was very different from a place we see today. The space between the newly formed planets was full of debris, and collisions were commonplace. Large asteroids, we call the planetesimals, were constantly hitting the Moon and the other planets. A shard from such a collision could have reached the orbit of Mars when the planet was still forming and was trapped in its Trojan clouds. A third, and perhaps a more likely scenario, is that the object came from Mars itself. As Dr. Christou points out, the shape of the 101429 spectrum tells us that it's rich in pyroxene, a mineral found in the outer layer or crust of planet-sized bodies. Mars, like the Moon and the Earth, was pummeled by impacts early in its history. That's what we call the early bombardment phase. Pummeled by impacts early in its history. One of these was responsible for the gigantic Borealis Basin, a crater as wide as the planet itself. Such a colossal impact could easily have sent 101429 on its way to the planet's L5 Lagrangian point. Indeed, a Mars origin was proposed a few years ago for 101429's Trojan sibling, a cluster of Trojans collectively known as the Eureka family. These asteroids also have an unusual composition, but whereas 101429 is pyroxene rich, these Eureka family asteroids are mostly olivine, a mineral found deep in the planetary mantle. 101429 and its brethren also have something to teach us about finding the Earth Trojans if they exist. Previous work by the team had shown that solar radiation causes debris in the form of boulder or city block-sized chunks from these asteroids to slowly leak out of the Trojan clouds of Mars. If the Earth Trojans are anything like Mars, the same mechanism would act as a source for small, near-Earth asteroids that will stand out because of their uncommon composition. Finding these objects might turn out to be a job for the Vera C. Rubin Observatory, poised to begin the most ambitious survey of the solar system to date. Rubin is expected to discover roughly 10 times as many asteroids as currently known, along with Gaia satellite already surveying the sky from the L2 Earth-Sun Lagrange point, may offer us the best near-term prospects for tracking down the debris of Earth's Trojan companions. And this is provided by Armagh Observatory and Phys.org. Please leave your comments. Thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.